Yeah, yes.
Now going to see what is in a graph theory. Before moving to graph theory, we have to know what is in a graph. A graph is a generalization of simple concept of a set dot, edges and vertices or an arcs. Charan,
Pragdish. No.
graph theory.
Graph theory. Yeah. Hello.
Mm, ah, okay. Graph is represented by G, and the points where V and E. V represent the vertices denoted by V are V of G, and E be the set of edges denoted by E or V of E. The graph theory is a part of descriptive mathematics and the useful structure to model a relationship between the objects. Where the points which two lines are connected, the lines are called as an edges, and the points which connects two lines is called as an edge. Next, now what are the applications of graphical theory? There are a number of applications related to our day-to-day life. These three are an important application nowadays. First is on computer network, and next cloud computing and internet. Next, what is computer in computer in network? And computer network is a set of computer sharing resources located on or provided by the internet nodes. Each computer can be assumed as a node in a graphs, where the examples were WAN, wireless local area network, and CAN, campus area network. Next. The graph theory is used to find the shortest path in a road or a network. In Google Maps, various locations are represented as in a vectors or a nodes, and the roads are represented as an edge. And the graph theory is used to find the shortest path between two nodes. For an example, if we take an direction between Chennai to Bangalore, the Chennai and the Bangalore were the vertices, and the path which connects then Chennai and the Bangalore are the edges. Next, cloud computing. Cloud computing is a technology that uses the internet for storing and managing the data on a remote service, and they access data via internet. Sorting is in different file or in folders makes a classification easy. Example, Google Cloud. Next. Internet, it is on one of the largest graph in the world. In a web search engine like a Google, it search for an web pages where the pages on the internet are linked with each other, other by the hyperlinks, and the web pages and the sites are connected by the rank, and the pages are allowed the Google display the best pages at the begin. Next. Now we're going to see the machine learning. Machine learning is all about the max, which in turns to help in creating an algorithm, then can learn from the data to make an actual prediction. Machine learning also, the machines are learned through experience. Machine learning is an buzzword for today's technology, and its growth were rapidly day by day. Next. Okay, AI is a subset of machine learning. For an example, YouTube videos recommendation, Google News feedback, auto driving cars. Next, okay, let us consider a construction where the rooftop is in machine learning, where the foundations of this rooftop is in fully full of mathematical theories. Where the important mathematical theories were linear algebra, analytic geometry, matrix decomposition, vector calculus, probability and distribution, optimization. The main criteria which has been followed in the machine learnings were an linear algebra, calculus, probability, statistics. These are the main criteria for which is following and which are used in the machine learning, where the pillars are the supporting the foundation and the machine learning. One is an regulation, another is an dimensionality reduction, density estimation, and the classification. What is linear algebra means? It is an about to study of a vector and some rules to implement this vectors. The concept of the linear algebras are widely used in the developing algorithm in a machine learning. It enables machine learning algorithm to run a huge number of data sets. It helps in optimizing a data. What is in calculus role in machine learning? The calculus mathematics is an integral point of machine learning, but according to it, only a knowledge of a basic concept is necessary for implementing an machine learning. Then important application of a calculus in machine learning is to gradient descript an algorithm. What is in probabilities roles is to always an important and interesting part of an mathematics, which measures the likelihood of an event. Machine learning is also helps in the predictioning the likelihood of an future event. It requires the work with an machine learning prediction and the modeling project probability density functions. Statistic, it helps in drawing a logical conclusion from the given data. It is a criteria concept that even machine learning engineers or scientists must learn to understand the working of a classification algorithm, like logic regression and hypothesis testing in machine learning. It helps to understand the data and the transfer of sample observation into an meaningful information. The pillars are regression, dimensionality reduction, density estimation, the classification. What is regression? Na? It is a technique for interviewing the relationship between an independent variable or a feature and the dependent variable. It is used as a method for predicting the module in a machine learning, in which an algorithm is used to predict and continuous and outcomes. What is a dimensionality reduction? It is a machine learning or a statistics technique of reducing the amount of random variable in a problem for obtaining a set of principal variables. A density estimation the involves in selecting a common distribution and the estimation the parameter for the density function for a data sample. Classification role is it is a supervisual language concept which is basically categorized and set of data into a class. The most common classification problems are face detection, document clarification. Where the graph is divided into two parts, the one two edges and the two vertices and one edges is splits the two classes where the A classes and two classes. The role is classification. Next. Next, what are the applications of machine learning? Um, an automatic language translation, medical diagnosis, stock market trading, online fraud detection, visual personal assistant, email spam and malware filtering, self-driving cars, protectioning recommendation, traffic prediction, speech recognition, image recognition. These are the main concept which are being used in the machine learning. And next will be explained by the Charan.
Okay, fine, Pradesh. Coming to my topics, cryptography. First of all, we know what is cryptography. Cryptography is nothing but it is the study of secure communication techniques that allows only the sender and the intended recipient of a message to view its contents. The word crypto is from Greek. It means the word crypto means hidden. And coming to the PPT, cryptography is the science of using mathematics to hide data behind encryption. Before knowing that, we have to know what is encryption. Encryption is the type of mathematics specially used for security purpose. Nowadays, most of the data transmitted is in the form of online mode. Here, the question arises about security. The security can be given by using encryption. For a better understanding of the encryption, let us consider a person A and a person B. If a person A send a message hi to the person B without encryption, it can be easily accessed by the hackers. Neither active hackers or passive hackers. There are two types of hackers. That is active and passive. If the encryption is included, that means if a person's if a person A send the message hi by using encryption, and that can be coded as 1 2, it can only decrypted by the person B be on the other side. But when the hacker tries to access the data, he can't understand the code 1 2, which can only decrypted by the user B using his public or private key. And coming to it involves and the cryptography involves storing secret information with a key that people must have in order to access the raw data. As I said about encryption, the major fields of mathematics like number theory, field theory, and coding theory play an important role in cryptography for security purpose. And second one is the third point is encrypt and decrypt is similar to data plus key. The mathematical algorithm ensures that the cheaper text can't be read unless the key are used exactly as intended by the equation. Here we can see the flowcharts shows that plain text after encryption, it cannot be accessed by anyone other than the user on the other side. He knows the public key of that. Example here are the examples of cryptography. Let us consider A and B, which is the multiples of 6 is equal to B into B. It can only decoded using mathematical applications. Coming to the final topic, game theory. Game theory game theory is totally mingled with the mathematics. Game theory is the mathematical mode which is used for decision making statements. Game theory is the branch of applied mathematics that provides tools for analyzing situations in which parties called players can make decisions that are independent. There are there are three types of decision making. So first one is deterministic, second one is probabilistic, and third one is uncertainty. If we discuss about game theory, it has a major role in all the fields. It can be included in many colleges as a separate subject. It is primarily used in economics, political science, and psychology. And a game is a mathematical sense is a situation in which player can make rational decisions according to the to defined rules, which is can be done using the probability. Example for the game theory are poker games, rock, papers, and scissors. And coming to the end, apart from these applications, there are lots of applications of mathematics in modern technology, such as robotics. Robotics can be involved in robotic involves totally algebra. And second one is drone technology. Drone technology involves trigonometry, geometry, linear algebra, differential equations. All are covered in the construction of drones. And third one, GPS. GPS is also a GPS uses a mathematical mode to calculate the present situation of a moving vehicle based on the previous measurements of its position. And artificial intelligence involves linear algebra, and virtual reality involves calculus, analytical geometry, and so on. And here, coming to the conclusion of our PPT, we ended with a wonderful quotation said by Carl Friedrich Gauss: mathematics is the queen of science and arithmetic is the queen of mathematics. Thank you.
Wonderful presentation, Ma. You have covered almost all the topics. Very nice presentation. And you can use it in further for your future work also. It's a
Yes,
nice
okay.
presentation, Ma. Very good effort done by the presenters.
Thank you, ma'am. Thank you.
Thank you, ma'am.
Aisha ma'am, any comments from this side?
Thank you. Thank you for the good presentation. Actually, I think all the topics you covered. Nice presentation.
Thank you.
Especially machine learning.
Thank you, ma'am.
Okay, students, thank you so much. Next, we move to Sharmi and Subhashni. Before going to the Shamir and Subhashni presentation, Sanjay Kumar, Mohammad, Roshan, and Praveen Kumar, are you available? Sanjay Kumar, Mohammad, Roshan, and Praveen Kumar.
Yes, sir.
Team 6 is ready right now. Ready?
Sir, we are ready.
You
Sir?
just Sanjay Kumar, Mohammad, Roshan, and Praveen, are you ready, ma'am?
Sir, yes, sir.
Yeah, okay, fine. After the Sharmi and the Subhashni, you can proceed. Okay.
Yeah, okay,
Yes,
sir.
We prepare for that. Now over to Sharmi and Subhashni. Thank you.
Camera on. Good evening, everyone. This is Sabeshni Mohan from IT2. I am Samren from IT2. The topic that we have chosen to talk about is cryptography. Our friends have shared what cryptography meant, and we are gonna explain the whole details about cryptography. Those are the topics that we are going to talk about. We should give a brief introduction about cryptographies, then we talk about its terminologies and how it works. And there are different types of cryptography. We will explain it later in the PPT. Then we will explain how cryptography is used in maths, and we will talk about the history of cryptography. First, let us give a brief introduction to cryptography. So what cryptography means is it is combined by two words, crypto and graphene. The word crypto means hidden and the graphene means writing. It is not actually hiding and writing something. It's actually if you write something and the message will be hidden from the intruder. It will be only received by the receiver. It is actually the study of secure communication techniques that allow only the sender and intended recipient of a message to view its contents. So, Sabeshni will explain.
Dear students, please, sorry to disturb you. So, both of the students, please open your video, then we can proceed.
This is okay, sir? Sir, are we visible?
No, right now. Sharmi.
Connected in the single device, ma. Both of you are in the same device.
Yes, ma'am.
Then
Okay.
one
Fine.
by one come to the frame, ma. Because only half portion of you are visible. First one, yes.
So
Yes,
now,
okay, fine.
Sabeshni will explain the terminologies about cryptography. Before going into what cryptography means, we should talk about all of its terminologies. There are several terminologies we have to understand before knowing about cryptography. Our classmates explained many of those things, but let us explain it more clearly. Encryption. Suppose someone gave us a plain text named hello, and we have to send it to someone else without the other person knowing what we sending to the recipient. So we have to encrypt the text hello by using, we have to encrypt it something like 1 2 3 4 5. The only thing we and the recipient, both of us only know what that means, so we have to encrypt the text. Then decryption means the 1 2 3 4. If there is a text like 1 2 3 4, we have to convert into a plain text. That is the decryption process. And the plain text means what the message that we want to convey to the recipient. That is what plain text means. Okay, Sabishni, what will be the ciphertext then? Ciphertext is about the text 1 2 3, that the code that is unintelligible to anyone other than the sender and recipient. That is what ciphertext means. Oh, is it so? That's very awesome about that. Then let us know about algorithm. What algorithm means? We know it is used for in our PSPP or programming in C subject. Now here algorithm means a mathematical formula used for encryption and decryption. And cipher is an algorithm used for encryption and decryption. Now the important topic about the cryptography is that key. A key is the value used by algorithm to encrypt and decrypt. Okay, let us now see about how cryptography works. Okay, so cryptography, there are many ways of working in cryptography. First, there will be a plain text given, which is like, hi Samran. That is a plain text. And you have to change it to an unintelligible text, which is ciphertext. You have to change into a ciphertext. That process is called encryption. Then after we done the encryption process, we will get ciphertext, which is the 1 2 3 4 5. which is some unintelligible text that only the sender and recipient can understand. And then we have to do a process called a decryption, which will allow the recipient to understand what the ciphertext meant. Then we will get the plain text. Then the recipient will get the plain text. That is how cryptography works.
Okay, now how cryptography work means. So let us assume that this is a key. Now, if I have to encrypt this key, I will give it to Sabeshni, and this way, this key will not be visible to anyone. You can see the key, but there is a message hidden in there. You will never see that. If I give it to Sabeshni, she will have that key, and she will decode it. Then she will know what the message is hidden in there.
So there are several types of cryptography. Everywhere we use maths, from ancient times to future. We always use maths. So cryptography is a science of using mathematics to hide data behind encryption. That is what cryptography is about. And one of the techniques of cryptography is a symmetric key cryptography, where we are given a basic key. Like here, for example, we are given a key which is 3, and they ordered all those alphabet, and the keys for A they assigned D, which is 3 letters away from A, and B they assigned E, which is 3 letters away from B. So that is how the key is given. Key is a constant value which were given for all those letters. So if I have to convert the word welcome into a cipher text, then I will copy it from the above example. So that is how symmetric key cryptography works. Then Samran will explain the next type.
So monoalphabetic cipher substitution technique is another technique which is somewhat different from what Sabeshni told. She told the key is 3 here in that case. Now the key here is randomly chosen in the combination and permutation of 26 alphabets. Monoalphabetic cipher substitution technique is used use fixed substitution over the entire message. Uses random substitution, requires permutation combination of 26 alphabets. It is very hard to crack. Then here is example given. It is somewhat differ from what we seen before. So the plain text here is welcome, and the cipher text is GXDLRPX. The letters chosen here is randomly substituted, and we made a cipher text here. Then
there are two substitution technique, like homophonic substitution technique and polygram substitution technique. For homophonic substitution technique, we assign many letters to a single letter. For like if there is a letter called A and we have to replace it by many letters like D, H, P, R, then it is called homophonic substitution technique. A plain text alphabet can map to more than one ciphertext alphabet. That is what I basically said. Then there is next technique, which is polygram substitution technique. A block of plain text alphabet is replaced by a block of ciphertext alphabet. It's called a polygram substitution technique. Like the word hello is replaced by some unintelligible text, which is called ciphertext. This is a type of a polygraph technique. Then let us see how cryptography works in maths. That is what we are going to explain. Someone will explain that.
So maybe some of you will remember what this picture means. It is actually a text from our 12th standard book, where we already studied about cryptography little. So we will given a matrix A, which will be encoded, and then it will be decoded to get the text. So the message to be sent is welcome. The key is chosen by the combination of a square matrix 3 into 3 matrix. So the key will be as 1, 2, 3, 4, 5 for the A, B, C, D to Z. So for the word W, we will use 23rd number, and for E, 5, L, 12, like that we will substitute all the letters by the numbers. So the matrix will be taken and it will be encoded. Then we will get the coded matrix by multiplying the uncoded and encoding matrix given Then we will have encoded message in the matrix form. By using matrix inverse, we will get decoding matrix, and by multiplying the encoded message with the decoding matrix, we will get decoded matrix, which will give the message as welcome. Then
So digital signature. What is cryptography used for? We want we as many of you think, like we are not using this in day to day life. This is usually in various field, like in our field, information technology, and in mathematics, in various field, cryptography is used. Digital signature. If you want to find out some message, if you got a message from someone, let me say Mebruka sent me a message, but I don't know who sent it to me. So if I want to find who sent it to me, I can use a digital signature, which is an electronic signature that can be used to authenticate the identity of the sender of a message. We can use it to identify the authenticate the identity of the sender. It is a mathematical scheme for demonstrating the authenticity of a digital message or document. Each signatory has its own paired public and private key. Key, as you all know, it is a constant value we use it to encrypt a cryptogramming into a ciphertext. And it can be a public key and private key. Private key is something that only those who can some of can use, like sender and the recipient. Public keys can be used by anyone. That is a public key. Then the types can be explained by someone.
so the types of algorithm in digital signature are a digital signature generation algorithm. It consists of a mathematical or digital signature generation algorithm. It randomly produces a key, like we already seen in mono algorithm. A signing algorithm produces a signature. A digital signature verification algorithm, it's another third type of algorithm. It consists of a verification algorithm along with a method for recovering data from the message.
So next, the process is signing.
Excuse me. Sorry to disturb you. It is very lengthy presentation you are going to present for the time constraint, and also give the opportunity to other students also. Please complete fast. Okay.
Okay, sir.
Fine.
So let
Already
us
it is 10 minutes to hour. That is why. Because we are also give the opportunity all the students, and also waiting in long time. Okay.
Okay, there are certain application of cryptography which is used for secure communication, identification, and authentication, and we can secret sharing, and for certification, e-payment. Cryptography is used, and it is used in from ancient techniques, from ancient time. Cryptography is used from World War II, World War One. There are many type of cryptographies used, and there are many code machines like Enigma, Sigaba, and Ultra, which were used in World War II. And that's it, sir. Thank you.
Nice
Thank you so
presentation.
much.
Both of you have done nicely. Content is also nice. Nice presentation. Best wishes, ma'am.
Aisha ma'am, any
Thank you,
words
ma'am.
about this?
Oh, it's nice presentation. Good, ma'am.
Thank you.
Your presentation about cryptography is nice.
Thank you, ma'am.
Thank you.
Sure.
Okay. We move to the next participants, Sanjay Kumar, Mohammed, Roshan, and Praveen Kumar. Fine. Before going to the sixth team, are you available? Raghav, Sarath, and Sushinder?
Yes, sir.
Available? Yes,
Sir.
okay. After the sixth team, we proceed with Raghav, Sarath, and procedures. So now the team 6 is going to present Sanjay Kumar, Mohammed, Roshan, and Praveen Kumar. Please, all this are the 4 members. Please open your video first, then continue your presentation. Thank you. Sanjay Kumar, Mohammad Roshan, Praveen Kumar.
Sir, yes, sir. 1 minute. Sir. Sir, is the screen visible?
Yes, okay. So your time duration is only 10 minutes. So please complete this within this prescribed time. Okay.
Yeah, sure, sir.
All the yes, all the best.
Sir, hello, sir. கேக்குதா sir?
Yes. Yeah, of course.
Okay,
You are
thank you.
audible.
Good morning. Very good afternoon to all who are gathered here. Today, we are here to talk linear algebra used in data processing and machine learning. Let me see little bit briefly on upcoming slides. We, Roshan and Sanjay Kumar, myself, are going to explain. Something we see simple introduction to machine learning. Linear algebra is basement for data science and machine learning. Most of the beginners starting out their learning journey in data science as well as machine learning. It develops the essential concepts in linear algebra and familiar between the strong and established practitioners. Linear algebra is a branch of mathematics that is extremely useful in data science and machine learning. Linear algebra is most important math skill in machine learning. In machine learning, most of the models can be expressed in matrix form. Like this, it can be represented. A data set also represented in matrix, but data set is itself represented as a matrix. Nothing but data set is it can, for example, in hospitals, some patients' records are stored in computers. That records is called data sets. Linear algebra is not only used in data processing and machine learning, but also in data transformations and model evaluation. Here are the topics you need to familiar with. Example, vectors, matrix, transpose of matrix, inverse of matrix, determinant of matrix, trace of matrix, dot product, eigenvalues, eigenvectors, convariance matrix. This convariance matrix will be briefly explained by Roshan, my friend. This import necessary libraries for linear algebra. These are the some codes used for machine learning and data processing. Data visualization. This is to define column matrices that tells us this graph shows that tells the stock price for 16 days in that like this some of the graphs are shown.
I am Roshan. I'm going to briefly explain you about the covariance matrix used in a okay. Covariance matrix is nothing but it is a measure of how much two random variables get changed together. It is actually used for computing the covariance in between every column of data matrix. The covariance matrix is also known as dispersion matrix and variance. These graphs are nothing. These graphs are explain. I will explain this. The first is the center of mass. The first is the center of mass. The center of mass is the point where you could balance this data set. If every point was an equal weight, we also call it the mean or the average. Then we also have the x variance, which tells us how much this data set is spread in the horizontal direction, and the y variance, which tells us how much the data set is spread in the vertical direction. As you can see, this data say a little more spread in the horizontal than the vertical direction. So we expect this x variance to be higher than its y variance. However, that does not tell us everything, because the data set could be an oval or a circle or different things. Some things that will tell us a bit more about the shape in the data. Set is the covariance in this case. It could tell us it's elongate and it point in this diagonal direction. So that tells us a lot about the shape of the data set, and then we can do things like fit a Gaussians to it, etc. So we have something called a covariance matrix, which encompasses a lot of this information, and it's simply the matrix formed by variance in the x direction and the variance in the y direction. That goes the diagonal, and the variance which goes in the place outside the diagram. Now, this data set is two-dimensional, so the variance matrix is 2 by 2. But if we add, for example, a 100-dimensional data set, then we have a 100 by 100 covariance. In this diagram, first we have to take the y-axis, and we can take the mean of the y-axis, and then divided by 4, because the 4 points are there. So we can have the value as 3 by 2. These are the general topics. From first picture, it is called as a negative covariance, because the diagram is from the range fourth quadrant and from the second quadrant. Zero covariance is nothing but it lies on the x-axis range. Positive covariance is lies between the first quadrant and the second quadrant. Compute the commutative variance. Since the trace of a matrix remains invariant under a unitary transformation, we observe that the sum of the 8 values of the diagonal matrix is equal to the total variance contained in features. Vectors, these are the topics we have discussed. Next, our mate Sanjay is going to explain about the linear algebra in this topic.
Hi, sir. This is Sanjay, and let me explain how data processing uses the linear algebra. Machines or your computers only understand the machine's learning numbers, and these numbers need to be represented and processed in the way that enables these machines to solve problems by learning from the data science instead of predefined instructions, as in the case of programming and the progression. Linear algebra for the data and the machine learning. These two assigns then solve the problems which uses the most of the data representation and uses the vectors, matrices, and running behind the scenes. The main areas that we enabled by will be explained by me briefly in the previous slides. By linear algebra or the data representation, the word embeddings or say vector embeddings or dimensionally reduction. And we explain the data representation using the vectors, matrices, and the tensors to represent the data is by the numerical values are called as data representation. As we know, the word embeddings are already used in the case of most of the programming languages like Java, C++, but there are still most of the C languages uses the word embeddings in the previous versions of the Python, like Python PyCharm and idle most of the items and programming languages. In my domain, the dimensional reductions matrices replacing textual data and so many words. Each word represents a different meaning, which might be similar to another word. But vector embeddings in the linear algebra allow us to represent these words more efficiently. Uh, okay. We talk about in this algebra basically deals with the vectors and operations on the vectors. So by numpy, this might be just a one-dimensional array of numbers, but geometrically this has both the magnitude and direction. So our data can be represented using a vector. For example, in this slide, I have shown that one row is this represented by this feature vector, which has three elements or components representing the three different dimensions. So n entries in a vector make it a n dimensional vector. I think you can catch this point. Space or void, which might can be easily usable in most of the terms. And in this case, we can see we have three dimension height and weight, and also the age. The next slide. Now, linear algebra can be seen in the action across all the major applications today by detecting a type of lung disease or a lung infection. All these data types are also used in the LinkedIn or a Twitter post or in any speech to text used in the Google. All of these data types are represented by the numbers and tensors. We run vectorized operations to learn patterns from. So here in the case, you can see there's a lung infection X-ray image, which is first converted into a tensor, then fed to a neural network. The neural network, after they're learning patterns from these numbers, then outputs a learned tensor. And then we finally get the prediction from that output tensor. This is my example shown in this for the linear algebra. Then the vector space transformation. When it comes to the embeddings, you can basically think the n-dimensional vector by being replaced by another vector that belongs to the lower dimensional space, which is more meaningful and the complexities. For example, there is a three-dimensional vector which is replaced by a two-dimensional vector. As you can see in this example, there is a left image shows that three-dimensional vector and the right one shows the two-dimensional vector. So basically think of a very large numbered dimensional space and then converted into a lower dimensional space in a real world scenario. Finally, you can think of embedding as well as a 2D plane being embedded into a 3D space. And that's where this term embedding comes from. For example, you think that you are standing in a 2D ground plane, which is then embedded into a space in which we live. So that's the 3D space. Let me give a short note. If you are standing in a 2D real 2D plane, is that shows the left image shows the 2D plane and the right image shows that the 3D plane which we are living in this real world. So now let me give a real world examples to relate all these discussions of vector embeddings and all these stuffs. All these applications that are giving you personalized recommendations or using vector embeddings in these some form. Most of us uses the Netflix, YouTube, and Spotify and Amazon. Most of these uses the network embedding systems from the from the favor of linear algebra. In some form of example here is a graphic form of Google scores on recommendation system. Recommendation system which uses the PageRank algorithm in some kind of stuffs where we are given the data on the different users and their preferred movies. Some users are kids and others users are the adults. Some movies were all-time classics while others are more artistic. Some movies are targeted towards the young order audience, kids, while movies like Memento need to find a smaller dimensional vector representation that capture all of these features. So a very quick, for real quick, I will give a quick example way to understand how we can pull this task in by understanding something called matrix factorization, which allows us to break a large matrix down to a smaller matrices. Now ignore the numbers and the colors for now and just try to understand that how we have broken down, which I'm saying now. Here we have this matrix of 4 cross 5, which has 4 rows and 5 features, which was then broken down to 2 matrices, one of shape 4 cross 2 and the other of shape 2 cross 5. We basically have new smaller dimensional vectors for users and for movies and the horizontal. For the horizontal one, for the movies, and the vertical one is for the users. I think we have learned this before uh, in the school syllabus. Is which is a favor of linear algebra in this matrices. Also, this image I have taken from the Google, which recommended in the source of tnet.com.
Okay, students. Sanjay Kumar, sorry to disturb you.
Yes.
You have a very large amount of time to present your presentation, so it is going very nice also. So that is why I'm also forget to remind the time constraints it's in this conjunction. So
Yeah, 1 minute.
can you conclude this session very
Yes,
soon?
sir. Yeah, just do
Yeah.
two slides.
Thank you.
Yeah, thank you.
Yeah. Okay.
Let me give a quick important topic in this dimensionally reduction. In the case of in short of time, for this dimensional reduction, it is goal to narrow down or search and analysis to a low number. This is a very important topic. Please give time to listen. Analysis to lower numbers of dimensions. Analysis of a low number of dimensions and features. Our data points are all mentioned in the graph on the left of the band and the right of the band. The V1 is equal to minus 2.1 is refers to the features of data points are often clustered along a line, which I'm saying is left side. Please go refer to it. The lower dimensions and this is a positive matrix which and this is a positive covariance matrix which Roshan said before. We are basically looking for that principal direction that explain most of the data, which is using the concept of eigenvectors in the linear, which we have learned before in the semester one. And there are more stuff to explain, but in short of time, let me give a short conclusion in this. These are the common use of cases in the linear algebra or statistics, chemical physics, genomics, word embeddings, neural networks of deep learning. robotics and image processing, and quantum physics. These are the also the NumPy of linear algebra. NumPy as a dedicated NumPy is actually a Python programming company. It is a faster because of C language, plethora of mathematical and scientific functions available. It uses the linear algebra and also the data processing for the machine learning. Let me give a quick conclusion for this. We explained all we three, Praveen, Roshan, and myself for this presentation. I would really thank for this opportunity to this management and for you all for a quick hearing process. And really thank to our class mentor, Mr. Captain Prabhakaran, on this session. Thank you. Thank you, sir. Thank you all.
Okay, so thank you so much, ma'am. Visi ma'am and Aisha ma'am, please come in.
Yes, sir. It's a very wonderful presentation, guys. You have taken a very challenging topic and you have presented nicely. Your topics are very good, and we have actually learned a lot about the applications of linear algebra from your point of view. Nice presentation.
Thank you.
Thank you, ma'am. Thank you.
Thank you, students. Nice presentation. Ma'am, like ma'am said, we to learn from you. That is a topic called like linear algebra. We have many applications, machine learning and etc. So very enjoyable, nice presentation.
Thank you, ma'am.
Thank you.
Thank you.
Okay, thank you so much, guys. Next, we move to the Raghav, Sarath, and Susinder. Before that, we confirmed the next participant, 7, I think, Sridevi and Sam Ruben. Are you available?
Yes, sir. We are
Yeah, Sridevi, Sam Ruben, you just be ready for the next presentation. Right now, we move to the presentation given by Raghav, Sarath, and Susinder.
Sridhar and Samru.
Sridhara. Sridevi இருக்குப்பா. Sridhar and Sam Ruben. Okay.
Yes.
Okay. So now, Ruben, Sarath, and Susinder team, you can start your presentation. Right?
Yes, sir.
And also, please, students, keep in the time constraint along with you. So, anytime I insist to stop this presentation. Okay, just constrain yourself and present your presentation within the time constraint.
The screen visible. Is the screen visible?
Screen is not presented. 0 out of 0 is showing here.
Yes, sir.
Yeah, start.
Okay.
Yeah.
Good afternoon to one and all. We IT students Raghav Govindarajan and Suchinder will present on the topic of the usage of mathematics in speech recognition. So, let us start with a simple question. How does speech recognition work? So, speech recognition works by breaking down your voice into individual sounds. And these individual sounds are converted to a digital or binary format and then processed by the computer. Now, how the computer actually does it can be broken down into 3 processes. The main technology or the main mathematical model used here is models involving statistics and probability. Each language has its own set of vocabulary, grammar, and pronunciation. And even within a language, several words are used in different ways depending on the context. The computers use algorithms based on these statistical models and give us our desired outputs and identify our noise or voice.
Sir,
So let us study this.
ஸ்டார்டிங்ல காலேஜ் லோகோ போட்டிருக்காங்க நம்ம இதுல போடலன்னு நினைக்கிறேன்ல
Sir, can I continue?
Yeah, of course. Some of the students unmuted and talking something else. So I muted that person, so we can continue. No problem.
Yes. Okay. Now we'll study
Yes,
sir.
Raghav, Sarath, and Susin, all these three members are presenting here right
We
now.
joined the meeting, sir. So me and Suchinder are presenting now.
Yeah, okay. Of course. Thank you.
Okay.
Proceed.
So let us study this with an example. Let's say we take a 3-syllable word. For example, we take the word potato. Now the following tree shows us the statistical probabilities of how the speaker may pronounce the word. So it may start as potato or potato, depending on different accents. Now, this tree indicates us that there is a 60% chance that the first syllable will sound like po, and there's a 40% chance of sounding like pa. And using these probability, it actually determines what word the speaker is speaking. Now, these probabilities can get more complex the more syllables there are in a phrase. So, for example, this set of words here can be identified by the computer as recognized speech. But if we just do a small amount of changes in the way we say it, or maybe if we try saying it a little faster, the computer may misinterpret this as wreck a nice beach. And why does this happen? This happens because there is a vocabulary of around 60,000 words, and combinations of sentences can give us around 216 trillion possibilities. And there is a mathematical model that will particularly focus on, which actually deals with all these situations. And this will be presented by Suchinder.
Hello. Raghav, any inconvenience happened?
Yes, his mic is not working.
Okay.
I tried it. Okay, moving on, we'll talk about the hidden Markov model. The hidden Markov models, or HMMs, are a class of probabilistic graphic models that allow us to predict a sequence of unknown from a set of observed variables. The main principle of the hidden Markov model is that assuming we know the present state, we do not need any historical information to predict the future. This model is widely used for predicting outputs based on input speech given by the speaker. The same model is also used for machine learning and AI algorithms. So let us look more at the hidden Markov model. So given by this diagram, you can see there is a set of states, and for for an HMM to be characterized, we need a set of states, some transition probabilities between these states, where each Aij in this set is the transition probability from state I to state J. Uh, Observation probabilities, each defining the probability of an observation, is being generated from the state. The initial state distributions are also required, and the HMM is complete if all three of them are specified, and they are all kept together in a set named lambda, which is shown in the which can be represented visually through this diagram that is given here. This statistical model can also be used as the basis for a sophisticated speech recognition system, as shown here. The system was constructed using HMM specifically for the Romanian language. Similar models can be used for different languages depending on what language is used to train the algorithm. Thank you all.
Excellent presentation. My choice of topic is very nice. It's a very rare topic. We have explored a lot from your presentation. Actually, it's a new thing to us.
Thank you,
Very
ma'am.
nice. Your choice of topic is very excellent, ma.
Thank you,
Just
ma'am.
you can explore some more things and you make it as a paper and you can present or send it to any journal, man. Because the content is very excellent, but you have to add your input in extra. So I've taken whatever you have got information. You just take your own input and present in any conference like that. Next year you can have a symposium in department wise. You can go to the other colleges. So that you can enhance some more thing in this and you can present it. Nice presentation.
Yes, ma'am. Thank you, ma'am.
Yes, ma'am. Different presentation, different topic. It's very good presentation.
Thank you, ma'am.
Yeah, it is. Hidden Markov coding or model is a very new thing to read. It's not a new thing, but it introducing a new topic into our minds also. So thank you so much, Raghav. Next we move to the Sridhar and Ram Suruban. Ram Ruban, ready? Rolama. Sridhar?
Hello, sir. Yes, sir.
Yeah, okay. Before going to the start now, the last Raghav, Sushinder, Sarath, Sanjay, Roshan, and Praveen, please open your video for the small photo session. Sanjay, Roshan, Praveen Kumar Kingla, are you available? I think they left out. I think so. Sanjay, Roshan, and Praveen Kumar. Yeah, please come forward to open your video for the photo session. Raghav, Suchinder. Yes, and Sridhar, Sam Ruben also, please open your video for the single photo session also. So please students come first. open your videos first, then we'll start the next session soon. Guys,
Next team also will call them for video sessions. Sir. When the team has
Sridhar and Sam Rupan also. Hello, students. Any inconvenience you are facing to open your video?
Hello sir, I am Sam Ruban from my team. Sridhar illa sir. Altaf sir, my team.
Okay, if you change
Sanjay,
your
Roshan,
team
Praveen,
members means
only
you can properly inform and can proceed.
Okay.
Sam Ruben
And Altaf sir.
Altaf. Just now only you
Sridhar
informed us.
Sridhar is out of station sir, so he can't attend.
Okay.
Yes,
So
sir.
those who are presented, then only to make an account for the proper presentation members. Okay. So if your partners is not available, means you can alone you can present it. Okay.
Okay, sir.
It's not
Okay,
an
thanks.
issues. So please open your video, then we can take a small photo session. We move to the next presentation. Those who are available, Raghav just now only open this video. Roshan is just come for close வாங்க. Sam Rupan, open your video. Raghav, Susinder. இன்னும் கொஞ்சம் தள்ளி வாங்கப்பா. Sam Rupan, சுசீந்தர் பேக் லைட் தான் தெரியுது.
சுசீந்தர் பிளேஸ் மாத்துங்க, உங்களுடைய லைட் தான் ரொம்ப
பேக்ரவுண்ட் லைட் தான் தெரியுது. ஃபிளாஷ் லைட் தான் தெரியுது, வேற ஒண்ணுமே தெரியல. Sanjay Kumar and team எல்லாம் கொஞ்சம் ஃபேஸ் இன்க்ளூட் இன்னும் கொஞ்சம் தள்ளி வாங்க. பக்கத்துல யாரு? Yellow shirt. Yes. Okay, fine. Okay, thank you so much. Next we move to the presentation by Sam Rupan. Open it. And after this is Sam Rupan, the CHE2 student, Jayamati and Sam. Kanishka, are you available?
Sir.
Jayamati and Kanishka from
Yes,
CHE2. Yeah, you just please be ready for the next session. So, ready, Anava? Jayamati and Kanishka?
Yes, sir, we are ready, sir.
Yeah, okay. So, please, Sam Rupan, you can proceed right now.
Sir, can I share my screen, sir?
Yeah, of course. Ready.
Okay, sir. Hello, sir. It is visible, sir.
Yeah, ready. Visible.
Thank you, sir.
Okay.
Hello to everyone. I am going to tell about the topic topology, and I am Sam to tell about the topic in introduction of topology. Topology is a topic that studies the properties of surfaces, spaces, and variation under any continuous deformation. It is sometimes called as rubber sheet geometry. In topology, there are only two types of objects are used, the clay and the geometrical shapes, because the objects can be easily stretched and contracted like other rubber, but cannot be broken. If it is if an object is broken in the topology, it cannot come under the topology topics. For example, a square can be deformed into a circle without breaking it. This is a transformation of objects in geometrical way. but it cannot turn into a figure 8. Hence, the square is topological and it is equivalent to but different in figure from 8. And the next topic is about homeomorphism, which is come under the topology. And this is the main topic, that the notion of two objects being homomorphic provides the definition of intrinsic topological equivalence, and it is generally accepted the meaning of topological equivalence. Two objects, but two different structures, but it tells about the same equivalence of shapes and object. Thus, the extrinsic topological equivalence implies the intrinsic topological equivalence. From this shapes, we can see that the cube is deformed into circle, but there is no variation. There is only shape variation, but according to topology, it comes under topological shapes. The rubber band and the clay we can use for making circle, square, or torus. We can form any shape, but they are different in terms of only geometrical shape, but they are same in according to topology. That's the major in topology. What is topology? Topology is a mathematical study of properties of surfaces that is preserved through deformation, twisting and stretching, but not tearing is not allowed. In simple words, we can tell about the topology is a study of continuity and the connectivity. This is the principle. This is used in topology. Topological space. In topology, there is a structure called porous. Structure called porous we can see in this object. The donut shape diagram is called a porous. The set of tau are called open set of tau, is also called topology on X. There are two types of sets in topology: open set, closed set. The members of tau are called open set. The subset of X is said to be a closed set. The next to that, the combinational topology is explained by the Altaf.
Good afternoon, everyone. I am Mohammed Altaf from IT2. The word topology is derived from Greek word topos, which means position or location. This name is appropriate for topology deals with geometric properties which are dependent only upon the relative positions of the components of figures and not upon such concepts as length, size, or magnitude. Topology deals with properties which are not destroyed by continuous transformation like bending, shrinking, stretching, and twisting. Discontinuous transformations such as cutting, tearing, and puncturing are not allowed. Topology emerged as well-defined mathematical discipline during the early years of 20th century, but isolated instances of topological problems and precursors of the theory can be traced back several centuries. The first practical application of topology was made in the year 1736 by Swiss mathematician Leonhard Euler. Next, combinatorial topology. Combinatorial topology was an older name for algebraic topology, dating from the time when topological invariants of spaces were regarded as derived from combinatorial decompositions of spaces, such as decomposition into symmetrical complexes. The next, algebraic topology. Algebraic topology is a branch of mathematics that uses tools from abstract algebra to study topological spaces. The basic goal is to find algebraic invariants that classify topological spaces up to homeomorphism, though usually most classify up to homotopy equivalence. Although algebraic topology primarily uses algebra to study topological problems, using topology to solve algebraic problem is sometimes also possible. For example, allows for a convenient proof that any subgroup of a free group is again a free group. The next, differential topology. Differential topology is a study of properties of structures on manifolds that have only trivial local moduli. Differential geometry is such a study of structures on manifolds that have one or more non-trivial local moduli. It is a subject in which geometry and analysis are used to obtain topological invariants of spaces, other numericals. Some examples are degree of map, the Euler number of vector bundle, The genus of surface, the cuboid is some class of a manifold. The rest will be continued by Sam Rubin.
Yes, by the Altaf, we know that the topology is major information. I am going to tell about the uses and the future scopes of topology. We know that topology is study of connectivity and continuity. The topology is also used in other network topology. In networks, it is majorly used for many computer systems and Wi-Fi networks. Now we are going to see the uses. In network topology, there are bus topology, ring topology, star topology, mesh topology, and tree topology. There are 5 types of topologies are there. In bus topology, we are going to see all nodes are connected through a single cable known as backbone of cable. In the cable is known as a backbone cable, which in the backbone cable we can see that the many systems are connected through a one single cable. This is the principle behind the bus topology, which transmits the data from one device to another device using a single cable. This is the principle of bus topology. The advantages of bus topology is installation is easy, and the disadvantage, fault detection in this principle is very difficult to detect the error. And next to that ring topology, each device is connected exactly through 2 other devices from the ring. Data flow from one direction. The ring topology, we can see that the system is connected through a single cable to all the other systems. Data flow from one direction to another only by the clockwise direction. Anti-clockwise is not used in this method. The advantages of ring topology is easy to install, expand. Disadvantages, damages in one node affect the overall network system. Even the one network is a problem, it will be error effect to the another all systems. And more to that, mesh topology, from this diagram we see that it is each device is connected to every other devices through a link. Each computer is divided in enormous ways and links to other computers. From this, the advantage of mesh topology in the current situation is provided privacy and security. When compared to other 3 topology method, the mesh topology is very protective to many companies. And disadvantages means cost is very high. The cost of mesh topology is very high compared to others. And next to that, star topology. Star topology, all nodes are connected to central controller hub, which is used in troubleshooting is very easy. And the disadvantage is cost is very high. And last, the conclusion, we see the tree topology. And the tree topology is also the same as the star topology. All nodes are connected in a central hub to the devices which link through the single cable. And the advantage is easy to manage, expand easily. Disadvantages, one node problem causes all problems to every other systems. The cost is also high. Topology is not only used in network. The topology is a pure mathematics. It is used in physics, computer science, biology, and more than that, the topological
What happened, Ma?
Hello, Sam.
Sam Ruben?
I think it's some network issue. They stuck, I think. So.
Some other team members?
Okay.
Okay. Hello, sir. Can you hear? Small network issues.
Okay, so
Can I
please
continue?
complete. Conclude this session. We will move to the next participant. Okay.
In computer science, topology is used in many ways. Topological data analysis. This technique is used from algebraic method of max in large scale of many IT companies and many program like Java, JavaScript, HTML are used this techniques. In biology, the topology plays a main role in various systems like nanostructure. In nanotechnology of biology, it is used. The knot theory circuit topology also used in this method. The knot is used to cut the enzyme of DNA, which is in a human body. That topology is also used in biological method. Topology is used in evolutionary biology between the phenotype and genotype. Conclusion, we are going to see the topological space. It is roughly speaking a geometrical space which is closed and divides but cannot topology space. Most general type of mathematical space allows limits connectivity, common types of Euclidean spaces, metric spaces and manifolds. Yes sir, this is the conclusion of this. Thank you sir.
Okay, nice, very good.
Nice presentation, Ma. Actually, very dry topic. Topology in maths is actually very heavy also concept wise, but you have taken that topic and have explored its applications. Nice, Ma.
Thank you, sir. Thank you for presenting the opportunity, sir, and to all faculty members. Thank you.
Thank you so much.
Actually, it's a different topic. Many people does not like this topic, topology, but you are taking a good effort, Mom.
Okay, so thank you so much. Next, we move to the CSC2, Jayamati and Kanishka. Before this, John Tennyson, Joshua Samuel, are you available from CSC2? Hello, am I audible? Yes. John Tennyson and Joshua Samuel are available. Yeah. Next, Kavin Robert and Manivanan. Kavin Robert and Manivanan. Okay, not available. So Kiran Raj and Ravichandran.
Yes, sir.
Yeah, please prepare for this next presentation. So Kiran Raj, Ravichandran, ready? Right now we go for the presentation. Yes.
Kiran Raj and Richardson.
Yeah, Kiran Raj and Richardson. Oh, Ravichandran, Richardson. Okay. Okay. Now we move to this Jayamati and Kanishka.
Sir.
Yeah, we can start your presentation.
Okay, sir.
Okay.
Sir, is my screen visible, sir?
Yeah, it is visible.
Good afternoon to one and all present here. I myself, S.R. Jayamati, and my friend Kanishka, we are going to present about the topic, the number 0. The number 0, it's a portal between a positive and negative numbers. We chose this topic because it's a unique topic, and without the number 0, no field of science can further proceed their discoveries. Let us know about what is a 0. 0 is a number and the numerical digit used to represent the number in numerals. It fulfills a central role in mathematics as the additive identity of the integers, real numbers, and many other algebraic structures. As a digit, 0 is used as a placeholder in place value systems. The Indian 0 or numerical 0, widely seen as one of the greatest innovations in human history, is the cornerstone of modern mathematics and physics, plus the spin-off technology and computer science technology. India, where 0 became a number. The concept of 0 as a written digit in the decimal place value notation was developed in India presumably as early as during the Gupta period, that is dated to the 5th century, with the oldest unambiguous evidence dating to the 7th century. Some scholars assert that the Babylonian concept wove its way down to India, but others, including those at the Project Zero, give Indians the credit for developing numerical zero independently. The Zero Project hypothesizes that mathematical zero, that is shunya in Sanskrit, may have arisen from the contemporaneous philosophy of emptiness or shunyanta, said Gobbets. According to the book The Crescent of the Peacock, Non-European Roots of Mathematics by Dr. George Grives Joseph, the concept of zero first appeared in India around AD 458. He suggests that the Sanskrit word for zero, shunya, which meant void or empty, and derived from the word for growth, combined with early definition found in the Rig Veda of lack or deficiency. Aryabhatta devised a number system which had no zero as a positional system but used to denote empty space instead of zero. Thus, he became the first mathematician in the whole world to use the concept of zero. The Aryabhatta, written by Aryabhatta, states that Sanantam Dasagunam Sadyat, from place to place, each is 10 times preceding. Zero and its operation are first defined by Hindu astronomer and the great mathematician Brahmagupta in 628. Brahmagupta is a follower of Aryabhatta. He developed a symbol for zero, that is a dot underneath numbers. But he too does not claim to have invented zero, which presumably must have been around for some time. Rules governing the use of zero appeared in Brahmagupta's Brahmasuputra Siddhanta, which states that the sum of zero with itself as zero and incorrectly division by zero as a positive or negative number when divided by zero is a fraction with the zero as a denominator. Zero divided by a negative or positive number is either zero or is expressed as a fraction with zero as a numerator and the fine quantity as denominator. Zero divided by zero is zero. An inscription on a temple wall of Gwalior, India, dates back to the 9th century and has been considered the oldest recorded example of zero according to the University of Oxford. Another example is an ancient Indian scroll called the Bankshali manuscript, discovered in a field in 1881. Researchers thought it also had originated in the 9th century. However, recent carbon dating has revealed that it was probably written in the 3rd or 4th century, which pushes the earliest use of zero back 500 years. This is the oldest data, that is the Gwalior temple's inscription of zero, the first usage which we found in temples. Brahmagupta developed mathematical operations using zero, wrote rules for reaching zero through addition and subtraction, and the result of using zero in the equations. The initial shape of zero was exactly the same as the letter O. It was only today that there is a distinction between the number zero and the letter O. Brahmagupta gave few equations on zero. We all know that anything added to zero is the same number and subtracted with zero is the same number. But when anything is multiplied or divided with zero, the answer becomes zero. His first 3 equations were correct, but he failed to express the product of the 4th one. He told it as zero instead of infinity. Later, it was solved by another Indian mathematician known as Bhaskar in his famous book Leelavati. Now, let's move on to know about Aryabhatta and the Brahmagupta. These topics will be continued by Kanishka.
Good afternoon to everyone present here. I am Kanishka from CSE department. We get to know about the great mathematician who gave the zero to the world, Aryabhatta. Aryabhatta or Aryabhatta I was the first major mathematician astronomer from the classical age of Indian mathematics and Indian astronomy. His works includes the Aryabhatya and Arya Siddhanta. Aryabhatta mentions in the Aryabhatya that he was 23 years old, 1600 years into the Kali Yuga. This mentioned year corresponds to 499 CE and implies that
He was born in 476. He called himself a native of Kusumapura or Patliputra, present-day Patna, Bihar. He studied at the University of Nalanda, Patlipura, and it was speculated that Aryabhatta might have been the head of the Nalanda University as well. Aryabhatta is the author of several treatises on mathematics and astronomy, some of which are lost. Jayamati? His major work, Aryabhatta, a compendium of mathematics and astronomy, was extensively referred to in the Indian mathematical literature, and he has survived to modern times. The mathematical part of Aryabhatta covers arithmetic, algebra, plane trigonometry, and spherical trigonometry. It also contains continued fractions, quadratic equations, sums of power series, and a table of signs. Aryabhatta is also known as father of Indian mathematics. He was the one who found the number 0 and place value system and gives the approximation value of pi. Brahmagupta. Brahmagupta was an Indian mathematician and astronomer. He is the author of 2 early works on mathematics and astronomy. Brahmasput Asindada, a theoretical treatise, and Kattangulathur, a practical text. Brahmagupta was the first to give rules to compute with 0. Brahmagupta was born in 598 CE, according to his own statement. He lived in Bilmala, Gujaresa, modern Bilmal in Rajasthan, India, during the reign of Chavda dynasty ruler Vyagramukha. He lived and worked there a good part of his life. Pruthudaka Swami, a later commentator, called the Bilmaracharya, the teacher from Bilmala. Brahmagupta composed the following treatises. Brahmasputta Siddhanta, composed in 628 CE. Kattangulathur, composed in 665 CE. Grahana Kanjana, scribed in a manuscript. Brahmagupta also gave the solution of the general linear equation ax square plus bx equal to c. Brahmagupta is most famous result in geometry in his formula for quadratic cyclic quadrilaterals. Area of cyclic quadrilaterals whose sides have A, B, C, D as lengths is Brahmagupta formula. A equal to square root of P minus A into P minus B into P minus C into P minus D. 0, a universal value. Today, we take it for granted that the concept of 0 is used across the globe and is the key building block of the digital world. But the creation of world 0 as a number in its own right. 0 is a strange number and one of the greatest paradoxes of human thought. It means both everything and nothing. Without 0, not just mathematics, but all branches of science would have struggled for clearer definitions.
0 is a tiny number, but never ignore it. Thank you for everyone to giving us this opportunity for presenting this presentation. Thank you once again.
Okay, ma, nice presentation. We have got information from you about the mathematicians and the number 0. Nice presentation, ma.
Thank you, ma.
Good presentation, ma.
Thank you, ma.
Brief about 0. Thank you very much.
Thank you, ma.
Okay, fine. Good presentation. So next we move to this Kiran Raj and Richardson. So CSE 2s, I just call some of the students. Please be respond if you are available. Mahalashmi Nityasri. No. Prabhakaran and Siddiq Ali. Muthuraman and Sabrishwaran. Okay. So then guys over. So next presentation, I think it is if any other students are available to present this paper except this Kiran Raj and this Richardson.
Sir, Mahalakshmi is present.
Yes, Mahalakshmi Nityashree இருக்கீங்களா? Yeah.
Sir, due to an emergency, Nitishri couldn't unable to attend the meeting,
Okay.
sir.
So you
Lakshmi,
want alone, you only alone to present this today's session. Okay.
no, sir, Lakshmi Priya, my another friend can join us, sir.
What are the who are going to present today along with you? Mahalakshmi?
Lakshmi Priya, sir.
Lakshmi Priya.
Yes,
Okay.
sir.
Fine. So you are the next. I think you are the last person to present this session. We just prepare for it. Now we go for this Kiran Raj and Richardson. So please, students, Kiran Raj and Richardson. So start your presentation right now.
Good afternoon, everybody. I'm Kiran Raj from CSE department. Today we are going to present the topic about relations and functions. Generally speaking, by relation, we usually understand some connection between two living things, like brother and sister, teacher and student, etc. We are quite familiar with these relations. Mathematically, we can also define a relationship between two elements of a set. A relation is said to be a function if the first coordinate of all the ordered pairs are not repeated. This is written as A tends to B. Every function from A to B is a relation from A to B, but every relation from A to B need not be a relation A to B. Given any two non-empty sets A and B, a relation from A to B is a subset of Cartesian product A cross B. Now let us see the relation relate functions. Let A and B be any two non-empty sets. Let F denote some rules which associate with each element of A, a unique element of B. Then F is a function or a mapping from A to B. It is denoted by function from A to B. All functions are relations, but not all relations are functions. A function is a type of relation that assigns exactly one output to each input. Suppose we are looking in a mirror. What do we see? An image or reflection. Similarly, for any ordered pairs in any Cartesian product, say A cross B, the second element is called the image of the first element. Elements and its images. Let function for A to B. A is a member of A. If A is mapped to B is a member of B, then the image of A is B. If B is the image, then A is its pre-image. Domain and codomain. Domains is the set of all first elements of ordered pairs in a relation R from a set A to a set B. Let function f A to B be a function, then A is called the domain and B is called the codomain of F. Range. Range is the set of all second elements in a relation R from set A to a set B. The set of elements in the codomain which are images from the subset of the codomain called the range of F. Is the relation F a function? If so, identify the function. Yes, sir. Hello? Sir, am I audible to you?
Yes, Pa, you proceed.
Yes. Yes, it is a function. A relation from a set A to a set B is said to be a function of every element of set A has one and only one image in set B. It is a one-to-one into function. Even and odd function. Even function. A function f is said to be even function of x if it remains unaltered in magnitude as well as in sign when x is replaced by minus x. F is even if f of minus x is equal to f of x. This x square is equal to 2x power 4. Cos x are even functions of x. Odd functions. A function f is said to be an odd function of x if it remains unaltered in magnitude but changes in sign when it is replaced by minus x. F is odd if f of minus x is equal to minus f of x. Thus, x plus 2x cube sin x are odd functions of x. Types of functions. Onto function, into function, one-to-one function, many-to-one function, constant function, identified function are the types of function. Explanation of types of function will hand over to Richardson. Richardson.
Hello, Richardson.
Am I audible, sir?
Yeah, of course.
Proceed. Happy afternoon, everyone. So let's see the types of functions as he classified. So first of all, onto function. Onto function. The mapping of function from A to B is called onto function. So consider that a set of A and B, so domain and codomain, in that the domain elements is correctly mapped to all the elements in the codomain. And if its range is equal to codomain B, then it's said to be onto function. For example, if a function is mapped to A to B, where A is element of 2, 4, 6 and B is element of 8, 9, 10, where both mapped to each element, since no element of B is left out, though this function is said to be onto function. Then next function is into function. The mapping of function from A to B is said to be into function if there is at least one element of set B which has no pre-image in set A. Now consider that element 1, 2, 3 of set A and in codomain A, B, C. Here the element 1 is mapped to A and 2 and 3 both are mapped to the B. And you can see that in codomain where the C is which left out, so it's said to be into function. Then one-to-one function. A one-to-one function, the name itself says that the every element in the domain A domain which has an element in codomain. The function which of function A to B is called one-to-one if the every element in the domain which has an element in domain B. For example, function A, 1 and B which map to 2 and C is mapped to C. Since no element of B has more than one pre-image in A, it is said to be one-to-one function. Then many-to-one function. As the name itself says, there is many elements in the domain which is mapped to one element in codomain. Now the mapping of function A to B is called many-to-one if two or more elements of set A correspond to one element of set B. For example, you can see here that A and B in the domain are mapped to the codomain 1. So which is itself a proper example for many-to-one function. Then constant function. Here the constant function, the name itself shows that the every element in the domain which is mapped to one element in codomain. Now a function of A to B which is mapped is called constant function if every element of A has the same image in B. So you can know that the every element in the domain which is mapped to a constant particular one element in B, so which is said to be the constant function. Then identity function. Let A be a non-empty set. A function which is mapped to A to B is called an identity function if each element of A is associated with itself under F. For example, consider that a function which is mapped A to B, where A is a set of 1, 2, 3, which is defined by f of x, which is equal to the function of x. So it is called as identity function. So that's it, guys. We are the presenters of CSE2, which is Richardson and Kiran Raj. So thank you for giving us the fruitful opportunity by this presentation. Thank you, sir.
Thank you so much.
Good presentation. Nice presentation.
Thank you.
Thank you, ma'am.
Very
Thank
good.
you,
Nice
Pa.
presentation. Yeah, okay. Next, before going to this next presentation, can we go for the small photo session? So, Kiran Raj, Richardson, Mahalakshmi, and last presentation. Jayamati and Kanishka, please open your video. Then we go for the photo session. The video on panina photo எடுத்து now we go for the last presentation of today's great function. Others, please come forward first. Kiran Raj, Richardson. Mahalakshmi. Okay, thank you so much. So, very wonderful presentations are going. So, it is end with Mahalakshmi and Lakshmi Priya. So, Mahalakshmi and Lakshmi Priya, you can start your presentation.
Sir, due to a network issue, நான் வந்துட்டு கனிஷ்கா ஐடி வச்சு பேசுறேன் சார்.
Yeah, okay.
சார் அவளுக்கு நெட்வொர்க் இஷ்யூ அதனால ஷேர் பண்ண முடியல. ஒரு 2 minutes கேக்குறா சார்.
Excuse me, Mahalakshmi, Lakshmi Priya, Nachma.
2 minutes sir, network issue.
Okay.
Hi guys, sorry for delay. Sir, am I audible?
Yeah, of course. Audio.
Myself, Mahalakshmi, and my friend Lakshmi Priya here. Lakshmi, change.
Lakshmi Priya மேலே enable editing ஒரு பாக்ஸ் இது ஐகான் இருக்கு பாருங்க, அதை கிளிக் பண்ணுங்க.
Hardy Ramanujam number 1729 is the natural number following 1728 and preceding 1730. It is the taxicab number and
Lakshmi Priya display is discussed.
Is it visible, sir?
Yeah.
Okay, sir.
Sir, we quit the meeting, sir.
What happened? Something else?
Oh, sir, it's lot of network issues, sir. So we can't continue, sir.
Okay, so no problem. So thank you so much of that. I appreciate your involvement in the math presenting this proper presentation. So I congratulate all the participants, those who are presented your presentations and your views and your things to even this. Yeah. Okay. Thank you all these students, and also I especially thank our panel members, Dr. T. Isarsi and Mrs. Aisha ma'am. Thank you so much, Aisha ma'am and Isha ma'am.
Yes, sir. Ma, don't Lakshmi Priya, don't get disappointed, ma. It's nothing. You can present it later on in any other occasion. So just don't get disappointed. Anyway, congrats for your effort. Congrats for all the team members. We haven't expected this much nice presentations from first year students. Thank you all for your kind cooperation and your active participation. Especially we'll thank the coordinator, Mr. N. Sundrakannan, and other coordinators of MathFest.
Sir?
Okay. Yes.
Yes, Lakshmi Priya?
Now the technical issue is over, sir. Can we do it now?
Yes, ma. Yes, you shall.
Yeah, of course.
Okay.
He related their conversation. I remember once going to see him when he was ill at Putney. I had ridden in taxi cab number 1729 and remarked that the number seemed to be familiar in everyone and that I hoped it was not an unfavorable omen. No, he replied. It was a very interesting number. It is the smallest number expressible as the sum of two cubes in two different ways. The two different ways are 1729 is equal to 13 cube plus 123 cube and also as 93 cube plus 103 cube. The quotation is sometimes expressed using the term positive cubes since allowing negative perfect cubes gives the smallest solution as 91. 91 is equal to 63 plus minus of 5 into 3 is equal to 43 plus 33.
Hello.
Numbers that are the smallest number that can be expressed as the sum of 10 distinct rates that have been dubbed taxi cab numbers. The numbers was also found in one of Ramanujan's notebook dated years before the incident and was noted by Francis B. Bessie in 1657. A commemorative plaque now appears at the site of Ramanujam Hardy incident at 2 Colonnade Road in Putney. The same expression defines 1729 as the first in the sequence of Fermat near misses, defined in reference to Fermat's last theorem. As number of the form 1 plus z cube, which are also expressible as the sum of two other cubes. 1729 is also the third conical number, the first canonical number, and the first absolute Euclidean pseudo-form prime. It is also a finite number. 1729 is also the third Zeisel number. It is a centered cube number as well as a Brownian-Cagnal number, a 24 gonal and 84 goal number. Investigating pairs of distinct integer valued quadratic forms that represent every integer the same number of times. Newman found that such a quadratic forms must be in 4 or more variables, and the least possible discriminant of a 4 variable pair is 1729. 1729 is the lowest number, which can be represented by a Lostman quadratic form a square plus ab plus b square in 4 different ways with a and b positive integers. The integer pairs a, b are 25, 23, 32, 15, 37, 8, and 43. 1729 is the dimension of the Fourier transform on which the fastest known algorithm for multiplying two numbers is based. This is an example of an galactic algorithm. The next will be continued by Lakshmi Priya.
Now we are going to see about Ramanujan. Srinivasa Ramanujan, born Srinivasa Ramanujan Iyengar, was an Indian mathematician who lived during the British rule in India. Though he had almost no formal training in pure mathematics, he made substantial contributions to mathematical analysis, number theory, infinite series, and continued fractions, including solution to mathematical problems then were considered unsolvable. He done his education in the following government arts college and Pachepas College, Trinity College, Cambridge. In Trinity College, he is Bachelor of Arts by Research in 1916. He was born on 22 December 1887, Erode, Mysore Kingdom, British India, and died on 26 April 1920, aged 32. Kumbakonam, Madras Presidency, British India. About Ramanujan, while the Ramanujan number is not his greatest combination, it is certainly a fascinating discovery that is easiest to remember among all of his discoveries. Ramanujan was fascinated with numbers and made striking contributions to a branch of mathematics, partitio numerum, the study of partitions of numbers. Srinivasa Ramanujan's birthday, December 22, was declared as a National Mathematics Day in 2012 by then Prime Minister Dr. Manmohan Singh. Coupled with this a movie based on his life, he has grabbed the attention of the non-mathematical population as well. Ramanujan compiled around 3,900 results consisting of equations and identities. One of his most treasured findings was his infinite series for pi. This series forms the basis of many algorithms we use today. He gave several fascinating formulas to calculate the digits of pi in many unconventional ways. He discovered a long list of new ideas to solve many challenging mathematical problems, which gave a significant impetus to the development of game theory. His contribution to game theory is purely based on intuition and natural talent and remains unrevealed to this day. He elaborately described the mock theta function, which is a concept in the realm of modular form in mathematics, considered an enigma till some time back. It is now recognized as holomorphic parts of mass forms. One of the Ramanujan's notebook was discovered by George Andrews in 1976 in the library at Trinity College. Later, the contents of this notebook were published as a book. Ramanujan's contributions stretch across mathematical fields, including complex analysis, number theory, infinite series, and continued fraction. Thank you.
Sorry for all the inconvenience and thank you for giving us this nice opportunity. Thank you, sir. Thank you, ma'am. And thank you all.
Okay, ma. Nice presentation, ma. Have taken effort. No issues for the technical issues. So don't get disappointed. Nice presentation, ma.
Thank
Thank
you.
Thank you, ma'am. Right, nice presentation.
Thank you so much. In this junction, I conclude this session with a great gratitude to Ms. Dr. T. Sersi and Aisha ma'am. Thank you so much. So we'll close this session. So participants having any issues or any top 3 presentations to be selected and results will be announced and informed to your through your class max staff concern. Okay, thank you so much. So all the participants and Nagarani ma'am is also available right now. So thank you, Nagarani ma'am. Hello, ma'am இருக்கீங்களா பேசுறீங்களா Nagarani ma'am? Hello.
Sir, thank sir.
Okay, ma'am. So we'll conclude this session. So all the participants
Sir?
will do.
Thank you, sir.
Hello. இப்பதான் வந்திருக்கு.
Sir?
சொல்லுங்க மேம். எஸ்.
Thank you, sir.
Can we...
Thank you for the opportunity, sir.
Thank you so much.
We also get
Thank you.
some